Hi everybody. Um, so in today's video we're gonna just do a quick demo of some of the large language model features that I've talked to some of you about. Um, so the overall idea is that there are going to be times where you may want to leverage some of these new large language model features in order to do some research or some work on some data or some documents that you may not want to transmit over an web-based API. So, anything particularly sensitive or anything particularly confidential, you may not want to send via the internet to some company. So, the idea of this is that you would have an on-premises system that is entirely locked down. It could even be entirely offline. That is to say that it would have no internet access at all. So using it wouldn't present any additional data risks over what you already have, coming from your original system. Depending on how you configure everything. So that's sort of the idea. So what I've got prepped for today are 3 examples of things that I've configured that represent just a small subset of the nearly infinite things that you might want configured for such a system. So the very first one that I'll show is an example of, well, why don't I bring up the system first? So in the end, once I've got this built for somebody other than me, they wouldn't see any of what I'm showing you right now. This is sort of back-end stuff. Everything would be built into this web UI that I'm about to show you that just runs a local web address. So it's not online, but it does have an address, if you will. But that address is a local address or a network address, not an online address. So the first thing that I'm going to demo is using a large language model to get insights from an interview. So there are many times when we do interviews with study participants or even with clients if we're some kind of practitioner. And we may want to keep those interviews as secure as possible for good reasons. But we still may also want to leverage large language models to get some kind of insights from them. So what I have here is an example of an interview that I did. Let's see if I have it pulled up. An example of an interview that I did with my sorry, excuse me, an interview that I did while I was in graduate school during a systems consultation class. So I was talking to somebody who worked at a business, and we were just sort of talking through some of their business processes. So what I'm going to do is I'm going to take this interview and I'm going to pass it to just a general chat large language model. And I am going to ask it, I'm going to give it a prompt, and I'm going to ask it some questions. So first, I want to make sure that my large language model understands what this interview is. I just passed you an interview that contains an or a conversation between 2 people, Jesse and K.A. Jesse is the interviewer, K.A. is the interviewee. Please give me a summary of K.A.'s thoughts, right? Maybe we just want a general idea of what our interviewee was reporting to us. You can see that it's thinking about it. Okay, and this is what it spat back to me. So it took about 10 seconds. Okay, oops, sorry, scrolled a little too high. So change management. So KA believes that change originates both from top-down and bottom-up approaches in their company, but it's not entirely consistent. They mentioned that changes are often driven by problems at the production level, where employees communicate issues to their supervisors, which is an example of their bottom-up approach. They talk about proactive versus reactive decision-making processes, right? And this, I think, might have been a semi-structured interview, so it sort of makes sense that some of these fall into, sort of categories that we might expect. But, the LLM picked up on all of this all on its own. So obviously you could pass in more than one interview, and you could ask for things like summaries overall. You could ask it more specific questions, right? You could drill down in and ask, like, what were some examples of what KA said about, let's do that. Give me some examples of reactive change that KA talked about. We'll see if it can find more than the one that it already gave us. So here are two examples of reactive changes mentioned by KA. So a Tech 3 handling amniotic fluid. KA mentions a situation where a Tech 3 was allowed to handle amniotic fluid, but it compromised the sample. In response, management made a decision to let the Tech 3 continue handling amniotic fluid instead of addressing the root issue. And client compromise. KA also talks about an incident where the company compromised a client sample and then made it a reactive decision to respond positively to the client by changing their procedures. So something happens and then they make a decision based on what happened, right? Reactive change. Okay, all right, so that's example one, right? These are just, tip of the iceberg of the sorts of things that you can do with a general chat LLM. But there are more, shall we say, nuanced or specific use cases that could be built in to an LLM system like this. So I've got two that I want to demo, and I let my battery get a little low, but we're going to do it anyway. So I've got this document insight rag that I'm going to show you guys. So let's say that we have a document that we want to get some kind of insights from. I'll go ahead and pull up. Actually, I forgot to push it, so just give me 1 second here. I'll probably clip this part out of the video. So let's see. I put this here. I'm going to take this. I'm going to put it here. Put it here. Put it here. Okay, so what I'm going to do is I'm going to pull up a manual that I might have some interest in using and just getting some insights from. So what I've got here is the SysA manual. So this is obviously something that I would not want to share online, and it is something that I still might want to reference. So, traditionally, and still something that we might want to do a lot of the time, is pull up the manual, search through it ourselves, and try and understand everything that's going on. That's still obviously super crucial. LLMs are never going to replace that. But it might be helpful to use an LLM as some kind of quick reference, right? So maybe we have some kind of question. So just looking at our index here, maybe we want like a very brief idea about what does the manual say about conducting interviews. Okay. So it's going to read the manual for us, and it's going to give us some insights. And you can see down here that it's processing. That manual is a little sizable, so it makes sense that it's going to take it a second. So according to the manual, it is essential that interviewers know how to respond and verify information from their respondents. The interviewer's role is to listen closely to respondents, probe for additional information when needed, and make the final decision on the best rating for each item. The manual also states that the interviewer should consult with as many respondents as necessary during the interview process to obtain accurate and complete information. It emphasizes the importance of integrating information from multiple respondents, right? I'll leave this here. You can pause the video and read the rest of it if you'd like to. But here's just an example, right? There are lots of times where we may have technical documentation that we have access to that is not public information, and we may not want to share that in any kind of more public way. So this is just one more example of how we might want to use a more self-contained LLM. So the final example that I have here is something called one-shot classification. Sorry, zero-shot classification. So LLMs are really good at understanding language. So if we have text data, such as when we record the goal attainment scales, and we ask students to set goals, we may want to classify those goals in various ways. So what I've done is I've taken some example goals that Shada and the rest of us actually published a paper on together. I had originally included that in a PowerPoint that I presented a while back. So this is the citation. And so I just took some of the goals from that paper. I took some of the goals that fell into the math, science, and ELA categories. And what we're going to do is we're going to tell the LLM that we want it to classify these goals as math, science, or ELA, and we're going to see how it does. So this down here is just an example of how you might structure things. So we're going to say the label is English, right? And we'll tell the LLM that this is a goal for improving in English language arts class. Okay, and then our second one here, we'll go ahead and make that one be math, and that's a goal for improving in mathematics class. And then finally we'll do science, and that's a goal for improving in science class. Okay, and then, oh, sorry, you got to tell it what column name. So in the spreadsheet, it's just called goal. And then we'll go ahead and hit classify text. All right, and this is what it spat back. So, okay, so the first one, it said, I will improve in English class by studying and writing essays. Okay, predicted label is English, and it gave that 0.98 for the confidence, right? So it got it right, and it was highly confident that it was right, right? In fact, all four of these first ones all mention the word English, right? Some of them even mention English class. So unsurprising that it got them all right, and it had high confidence. But let's look at this next one. Correctly solve 2 word problems every school day until Christmas. Okay? All right, so word problems. That's a little trickier. Now, as a human reading this, yeah, that's probably math. Okay? It wasn't super confident, but it was confident enough to put this in the math bucket, which is what we want. Having some trouble scrolling here. There we go. All right, so the next one, the next one here, improve and practice linear equations in algebra, right? So another math, 66% confident. Stay on pace with math assignments, math, okay, gave it a 98 for the probability. So, you know, overall it's doing pretty good with math. Down here, let's look at science. Okay, this first one, I want to get a higher than a C in earth science. Okay, it mentions science, so unsurprising, it's pretty confident when it says this one's science. This next one, though, to finish all labs the day they are due, right? It picked this one as science. It wasn't super confident, but it was smart enough to pick up on the fact that labs are probably science goals, right? So that shows some pretty good nuance understanding of English. So overall, this did a pretty good job with zero shot. Now, just to say, zero shot classification is what we call it when we pass a large language model, something like this, and it's never done it before, right? It's not like this model was specifically fine-tuned to tell goals apart between English and between English, math, and science, right? It's just using its understanding of English to separate those. And it did a pretty good job. I will say that it is possible to fine-tune models to make them even better at these sorts of things, or to help them understand things that, maybe we had given this something and it didn't do as good of a job, right? We could make it do a better job. Fine-tuning is something that I could help with, and then a system like the one that I'm showing you could come with a fine-tuned classifier for specific classifications. I would just need to know ahead of time what things wanted to be fine-tuned for. So anyway, those are the three things that I wanted to show you. I'd be happy to answer any and all questions. The one thing that I'll say before I turn off this recording is that the system as I've designed it would allow 3 concurrent users to do the sorts of tasks that we looked at today without stepping on each other's computing power. So the resources would be divided in such a way that what you saw today is the amount of computing power that every person would have, up to 3 different people. So, all right, that's it. Hope to talk to you soon.